Now we're going to graph y equals cosecant of 2 theta plus 2 pi. So we've got a couple of transformations happening here. This is going to transform it horizontally, shrinking it. This is going to be a phase shift. But before I can identify those numbers, I actually need to factor out k. So I actually need to write it like this, where I've got my value of k factored out, and you can see that that value is going to be a 2. So I need to divide that by 2, and that gives me pi. So you can imagine if you distribute that 2, you would get 2 theta plus 2 pi. And now I can see that my period will be changed. The parent function has a period of 2 pi, so I do 2 pi divided by k, which is 2. So 2 pi divided by 2 is pi. That means this will have a period of pi. The phase shift, after factoring out the 2, you can see that the phase shift is pi, and actually it's negative pi because it's going to the left, pi units. So to graph this, I'm going to start by graphing the inverse of cosecant, sine, as a guide, but I'm going to graph it with this period of pi. So, here we go. Sine goes from the origin. Since we want to draw a sine with a period of pi, since that's the period that this function has, I want it to complete one cycle from the origin to that point right there, which means it's going to hit maximum there, x-intercept there, minimum there, and then back to pi. So there's going to be one cycle of sine. All right. So if I do another cycle of sine, like that, and another one, and then I can move this direction as well. Another cycle of sine, another. Now I'm going to think about the phase shift before I graph cosecant. So what I want to do is I want to shift this pi units to the left. But you'll notice something really interesting happens here. If I shift this point, pi units to the left, it ends up right there. So when I do that, you'll notice it's back on top of itself. That's because this function has a period of pi units, so it repeats every pi units. So shifting it pi units will actually bring it back to where the original function is. So I've shifted it pi units right now. So the phase shift puts it back to where it started. So now I can graph cosecant by putting in my vertical asymptote. So at every x-intercept, there will be a vertical asymptote. So put all those in as dotted lines. All right, now in between each set of vertical asymptotes, I've got a parabola-looking thing that either is going up or down, and it hits that max or min of sine. So let's put them all in, and yes, they are pretty skinny, and they look like that. So let's put them all in. There's the graph.